Welcome to bLOOMbABY, our dynamic and engaging virtual garden app that leverages the power of Three.js. bLOOMbABY is a full-stack application consisting of Joey Reyes and Sam Putman on the back end, and Adam Bedient, Ed Chalmers, and Tom Coney on the front end. In bLOOMbABY, we simulate the lifespans of plants within a 3D environment, offering a nostalgic and interactive experience. Our app efficiently generates and visualizes unique plants in real time, ensuring every plant you see is one of a kind. bLOOMbABY's front-end framework was built using a range of technologies including React, React Router, JSX, Styled Components, Cypress, and Vercel. 3D visualization, rendering, and physics simulation were accomplished using Three.js, React 3 Fiber, React 3 Dry, and React 3 Canon. The backend leverages a Rails server, a Sinatra microservice for plant generation, and Heroku for deployment.
Hello, I'm Joey Reyes. The document that I'm going to be talking about is our technical document that helps streamline our process working with the front-end team. The back-end team created this to kind of cover the back-end side of the database schema and the endpoints that we're going to have. And the reason this helps streamline everything is because we could just post questions for the front-end team that they could look at, or also remind Sam and I to talk about during some of the meetings that we were having. And also keep some of our ideas that Sam and I talked about to bring up to the front-end team to kind of help become a more cohesive unit. And we came up with multiple different ideas. So this kept track of all those ideas. And then the document also has all the endpoints, which allows the front-end team to have a quick reference guide to see what endpoints they can use, and also what they should expect out of the response cycle. So this document was very helpful throughout majority of our project work time.
When it comes to scalability, the app is fairly robust. The backend is currently split into a Ruby on Rails app for routing and database management, with all the plant generation being handled by a very small Sinatra microservice. All that would really need to be done to expand functionality on our end would be additional data points to add to the plant generator for additional plant species. And for the Rails app specifically, we could look into utilizing a background job for plant generation, or caching our API responses.
Tackling Three.js for the first time was a steep learning curve. We faced complexities with its math-heavy syntax and the introduction of unique components like shaders, cameras, lights, and mesh materials. Understanding and mastering these components were crucial for achieving the desired visual effects and fully utilizing the capabilities of Three.js. To better understand how the various components and parameters affect our plant creations in real time, we built a demo sandbox application. This sandbox allowed us to experiment with different elements and variables in a controlled environment. By adjusting these parameters interactively, we could observe the immediate impact on our plant simulations. This hands-on approach not only helped us grasp the intricate workings of each component, but also enabled us to fine-tune and optimize our application for a more engaging and visually appealing virtual garden experience.
One particularly interesting technical challenge in our app was integrating a breeding mechanic into the game. With the goal of creating new, unique plants for every user, we wanted to introduce functionality that would cross the properties of two plants, while also introducing random gene selection and a certain degree of mutation variance, such that plant diversity could increase over time. To accomplish this, we wrote a robust function to handle plant breeding and integrated this into the flow of the app so that a user can explore the different combinations of plant aesthetics. In conjunction with our back-end plant factory, the possibilities have become endless. The next phase in the evolution of bLOOMbABY involves capturing these unique user-generated plants in data seeds that will allow one user to share a bred plant with another user, who can in turn plant this plant in their own garden, and so on and so on. Our hope is that, with appropriate user testing, we can create the kind of experience that inspires regular interaction with the game and other users.